You know what it is. Y'all know what time it is. It's your boy, the network. The network. It's damn phone. Back with another video, another live stream. We're going to do a little bit more OSPF today. Single area again, yes. So just in case somebody wasn't tuned in or somebody was tuned in yesterday and they didn't lab, now you can lab together with me. You know how I do. Yeah, I do this stuff. It's like what they say, the repetition is the mastery, is the key to mastery, right? So just doing this stuff over and over until we ingrain this stuff in our heads, right? Lab we're gonna be working with today, I believe, has how many devices? I think 3 routers and a switch. Let me go ahead and take a screenshot of that real quick. Now I asked in the Discord server if y'all wanted to use look at this crap, man. If y'all wanted to use this shit got so many damn ads. GNS3, I'm sorry, even G, or if y'all wanted to use even G or some real hardware, and nobody really responded, man. Just had one person hit me with an emoji and was like he didn't know either. So I'm like, you know, let me just go ahead and do even G because I don't feel like powering all these devices and stuff like that. So next time you guys want to see me ask a question and not get answered, go ahead and join the Discord server and watch me talk to myself over here. There is the link in the chat right there. I'll put it in the chat over there. We got Morningstar in the building. Bonnet, bro. What's up? Yep, I got my bonnet on today. Yeah, don't even ask, y'all. For anybody in here that's asking, Morningstar know what's up. We got Creed 9 in the building. Appreciate you for tuning in. Yes, I have my bonnet on today. For y'all that don't know, I'm growing my hair out, so I'm doing a little deep condition. So please do not, I'm standing in solidarity for my, sisters that like to wear their bonnet on in public. So you know what? Males do it too. I'm just not in public. I guess I'm at home, but I am on the web. So technically this is public, right? Whatever. Here is the screenshot of the topology. Let me go open up Paint so that way I can get my lecture on and stuff when we do it, right? Whoop. I know somebody been telling me about Microsoft Whiteboard. I'm just so used to using Paint. I've been using this shit since like, I don't know, like the 7th grade or something. So I know all the shortcuts. So I haven't, maybe I needed to try something new. Whatever the case is. So if you got even G or some real routers or whatever, GNS3, whatever floats your boat, go ahead and drag and drop 3 routers to your topology just like this. Or if you're using real routers, then go ahead and cable them up just like this right here. Notice this has a serial cable right here. I don't have any serial cables on my images, so I'm gonna just go with a fast Ethernet cable or gigabit Ethernet cable just like this, or gigabit Ethernet interfaces there, and that might change the way this lab works, but whatever it is, we'll still modify the cost. What we're going to do today is, here's the objectives, right? We got 9 tasks. We're going to do our basic IP addressing and loopbacks. We're going to configure single area OSPF. So just like yesterday, we're doing single area OSPF. Remember I said, just like repetition is the key to mastery. So we might do single area up until next week. Who knows? Until we all mastered it. And once we all master it, then we'll move on to multi-area. And I'm bringing you guys all along with me, right? So next task is advertise loopbacks, blah 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 blah. Either way, we got 9 tasks, and I guess let's go ahead and get started with the show. I'll drag and drop. What was it? 3 routers and a switch, right? 2 girls in a cup. IO. Where's that bad boy? Yeah, we want 3 routers right there. So 3 nodes. Go ahead and name them. You said the prefix. The prefix is just R. So I don't know what the fuck you talking about, man. I hope it say 1, 2, and 3. I hope it appends the number. There you go. Okay, good. So we good to go. And then router 1 is going to be at the top. No, I guess router 1 is here, and then 2 is here, and then 3 is there. So it's laid in succession, I guess, like that. Bloop. Come on, man. Come on, man. Isn't there a drag button? All right, that's what I was about to say. Y'all know I'm still getting used to even G. All right, 2 and 3. And then they wanted a switch in there as well. Add a node or an object. I'm in an object. I guess that's a node. So switch. There he is right there. Go ahead and just name him switch, I guess. Just one of those. Plug him up. Drag and drop that bad boy that way. We got Zaya in the building. Bless up, King. Bless up, bless up. Appreciate you for tuning in. What we got on the IT news, network news today? CenturyLink selling copper network in 20 states instead of installing fiber. They might as well just dish out dial-up to their customers, right? It still may, like, private equity firm Apollo will take on 1.3 million CenturyLink internet users. CenturyLink is selling large portions of their copper network in 20 states to a private equity firm, letting the telco pull out of rural areas where it doesn't plan to install fiber to the home technology. CenturyLink agreed to sell the networks for $7.5 billion to Apollo Funds, a private equity firm operated by Apollo Global Management. Apollo will also take $1.4 billion of debt. Let me keep this up I'll keep this up so while y'all do the labeling and cabling and stuff, right? So that will give y'all a head start while I'm over here reading the IT news and stuff. So they're going to take a lot of debt off of them. Now, from what I remember, yeah, CenturyLink got rebranded. I thought they like got bought out by another company, like Lumen. Okay, so I see it. Never mind. All right, so later on it tells you. So under the deal, I'll let y'all know, CenturyLink recently renamed itself Lumen, but still uses the CenturyLink brand name for residential and small business customers while using the Lumen brand for enterprise customers. And that's what we use at my job. That was one of our ISPs. Under the deal expected to close in the second half of 2022, Apollo will acquire the CenturyLink ILEC incumbent local exchange carrier business in the 20 states, including consumer, small business, wholesale, and mostly copper service enterprise customers and assets. So they getting all those customers, but they don't plan on updating their shit to like fiber. They just going to be using Ethernet. And that's why, we're still using Ethernet to this day, right? Because it just costs a lot of money to get fiber and install in these places, right? So we'll get the cabling from 0 to 0 here. Actually, just 0, just 0 to all of them, right? So from 0 to we'll do 0 from there, and then from 0 to here. Bloop. Y'all let me know what y'all using. Y'all using even G, GNS3, Packet Tracer. What else? PNet Labs. There's so many emulation software that's out there and simulators that are out there. Boson NetSim. You can actually create your own custom labs with Boson too. So believe it or not, they come with pre-made labs, but you could also create your own labs and share it with the community and stuff. So it's pretty dope. Y'all know how I feel about Boson. I like their products as well. Once I get to 5,000 subscribers, you guessed it, I'll be doing a giveaway. And the good folks at Boson NetSim, or Boson rather, they gifted me a free copy. So I'll be giving away a copy of that, so that way you guys can do it along with me and stuff, right? Y'all ready to go? Y'all let me know. CenturyLink is named Lumen. Yes, they rebranded it to Lumen, yeah. But that's just for their enterprise customers. Believe it or not, they still reference their company as a CenturyLink to some consumers. So, well, that's what they said, right? Isn't that what they said? Yeah, Century recently renamed itself Lumen, but still uses the CenturyLink brand name for residential and small business customers, while using the Lumen brand name for enterprise customers. And just like I said, like at my job, that's one of our ISPs, Lumen, but they still use the CenturyLink name with, just residential and small businesses or whatever. So first thing we're gonna do is task 1, configure addressing and loopbacks, right? So I guess let's go ahead and do that. That should be easy enough, right? I guess first thing we need to do is power these bad boys on. You can do all of them at the same time, right? Start all nodes, bloop. We should go there. I hope because y'all know my computer be acting up and stuff like that. Oh, that's what I should have done. I know I should have done. While those bad boys are powering up, let's let me see. Should we get some? Yeah, let's get some cabling here. I mean, some IP addressing here. We need one more cable going this way to this way. But this is a serial cable. Notice that. This is a serial interface. I don't think I got serial interfaces on these images. If y'all want to let me know how y'all can do that, but let's do that. We got to power these bad boys off before you do that. Let me power this off. Power this off. And then let's get one more cable going from here to there. And I don't have any serial, so it's got to be a gigabit interface. So that means when they want us to like try to find a different way, notice this is a serial link, right? So remember what we said about costs and OSPF and stuff like that? The slower the bandwidth, so like in this case, if we were using a CenturyLink interface, right? Let's say this is a CenturyLink serial interface, right? So the cost is most likely going to be 64. Right? There's default costs for different interfaces, right? Cost is going to be 64. So if we want to go this way, the cost might be like to this network, right? The cost might be, I think, for FA0, for Fast Ethernet. I can't remember what they all are. Let's just say for now it's 4. I can't remember. I'll bring them up. We'll Google it and find out, right? And it's 4 here, right? And it's 4 here. So even though it takes one link here and one link here and another link to go that way, actually you don't even have to do that. You just go link here and then link there to make it there. The cost is going to be 8. Even though it took then that's not even a hop. So it's just like, that's not even a hop. So either way, the cost is cheaper to go this way, right? As opposed to going this way, even though it's just like one hop away. But I'm not going to have a serial interface there. So most likely this is not going to be 64. It's going to be something it's going to be a gigabit Ethernet cost. We'll see what they are once we configure OSPF. So I'll just go from 01 to 01 and we'll figure out, we'll probably change the cost to simulate it like it's a serial interface. We'll do that. Start. And I think this lab actually calls for us to do that, right? Lab details. And I'll tell you. Lab details is right over here. That's priority. I thought I seen one in here that said cost. There it is right there. Cost of 50. So we're going to have to change them at one point. And then we'll do that. Yeah, we'll do that. We might have to do something on our own though. So those guys are powering on. Y'all ready to go? Y'all need to see the topology. I guess we'll put some networks to label this, right? Label the networks. Text. This is the 10.1.200 network. So the 10.1.200.0 / what? 24 network / 24. Well, can you bold it? Yes, you can. Yeah, I know I'm still getting used to even G, even though I've been using it for a couple times, but so bold that. And then come on, man. Look at this, man. This is not intuitive at all. What is this, man? There we go. Oh, there we go. All right, duplicate that. And then we want to make the other side, this right over here is, what network is that? The 10.1.100. Oh, that one is 200. That was 100. So this is the 100.0 network. And then the bottom one down here, let's see. We got some loopbacks down here. So we'll just, there's a loopback here, and here, right? So we'll do that also. Pete said OSPF cost equals reference. Yes. So that changes all of that, right? Once you put the OSPF cost on there. Let's duplicate that. Duplicate. And duplicate another one. Bloop. And we get another one, and then we'll just change them. I guess I should have done, I know I promised this too, that I was going to do the labeling and cabling before I start streaming. So that way we can just get to labbing and stuff. These 10.121/24. Why is it 12? Yeah, 10.121/24. So these 10.12.1/24, right? And then we got 10.131/24. So he's 10.1.3.1/24. And this other guy is 10.111. This guy right here. He's 10.111.1. Y'all let me know if y'all have any questions. I know we haven't even done any labbing yet. I'm just doing the labeling and cabling. Wheeling and dealing. Scoot that bad boy over just like that. So these are going to be loopbacks. Just keep that in mind, right? We're going to have interfaces over here and stuff like that. And we'll figure out what each one of those are. Like the .3 right here, that's .2, that's .2, etc., etc., etc. Right? We'll figure that out. I'm not gonna get that much labeling. So let's console in the router 1. Bloop. Close this up. Console in the router 2. Bloop. Console in the router 3. Where's router 3 at? Right here. Bloop. And they should be powered on. Let's see. Scoot those guys over just like that. Let me see if that screen looks enough so that way y'all can see all. No. And then I guess we'll start with router 1 and do the cabling there. He's supposed to be, he got a loopback. So he got this loopback. And then he's got that is 10. This right here is going to be 10.100.1. So we'll click no on all of them, I guess, because they all going to ask me, do I want to auto configure? And of course, we don't go through wizards, right? Because we're all network engineers here, right? We don't do nothing, we don't go through wizards and stuff here, right? We do all our stuff custom here. Y'all got any questions so far? I know we just getting started and stuff. And I've been saying that. I remember when I first started doing this live stream, I said, once we start doing the CCNP stuff, I'm going to do the labeling and cabling before we get started, before I start streaming, so that way we can just jump right into the lab and stuff, right? I really set myself up with that one, right? Because I'm just like, man, I come home and be like, damn, I got to stream today, man. It's all good, though. All right, so he is router 1, right? R1. And then we got an interface right here. What is that? That should be the gig 00 interface. He's .1. And then let's do the loopback first. Let's start with the loopbacks. Let's start with the loopback. Interface, loopback 0. His IP address is, no, that's loopback 1. It's actually loopback 1. You see that? See that? Let's pay attention here. He's loopback 1. That's loopback 3. And this loopback 2. So pay attention. Y'all see that? Glad I caught myself doing that. So let's do a no. Let's get out of that. And then we can remove the loopback with the no interface loopback 0, right? So no interface loop 0. That's not, we're not off to a good start here. Oh, lop 0. LO0. That removed it. That should have removed it. Now we're just going to do interface loop 1. And his IP address is 10.111 /24 255.255. I hope I did that right. 255.255. I hope I did that right. Let's see. 255.255.255. See, I got to do the logging synchronous on this as well. That's why I keep breaking up the typing. Jesus. All right, let's get out of this and fix that too. Line console 0 logging synchronous. Y'all see how it broke up my typing and I didn't know where the hell I was at? That's what this is, right? Get out of this, and then we'll go back to the interface loopback, which was interface loopback 1. And his IP address we said was going to be 10.1.1.1 /24 subnet mask .0. We'll do the other interface, which is this one right here. Remember, mines are gigabit Ethernet, right? So we're not working with CenturyLink here. Interface gig 00, and that IP address is going to be what? 10.1.100.1, right? Y'all with me so far? Let me know. This is just basic IP addressing and stuff like that we're doing here, configuring interfaces. We'll get to the OSPF part in a second. IP address 10.1.100.1 /24, which is 255.255.255.0. We got to no shut that bad boy. And then we got this other one, which was, I believe, gig. Which one was that? Because I don't have a serial interface on this one, right? So let's do a show IP interface brief. And it was what was the other one? I believe it was gig 00 that's connected. Let's see. Yes, it was gig 01 rather. Gig 01. So we got to do that one. Is going to be the 10. It's going to be .1 as well. Let's see. Let me see. I'll take that back. Okay. So here's the thing. This IP address needs to be 10.1.200.1. Right? And this guy is 10.1, so we need to fix that. Y'all see where I'm at? Interface gig 00. His IP address is actually going to be 10.1.200.1 255.255.255.0. That's what it is. Y'all see that? So this IP address, that's the network for this guy. He's pointing to that network. I was giving him this IP address, which is wrong. We in here. How long ago we started? We just started like not even 10 minutes ago. I was just reading news, talking shit, talking about my bonnet that I have on here. Appreciate the hard work you put in for us. Only a few minutes. Yeah, we only just get started, man. So just go ahead and I know you just popped in one, but just go ahead if you got even G or GNS3, just pop 3 routers in like this. 1, 2, and 3, and then put a switch right in the middle. And then we're just doing basic IP addressing and cabling and stuff like that. That's all we're doing right now. We haven't gotten to we're doing single area OSPF again. Yes, again, so this is not Groundhog Day. This is not a repeat episode. I just know that, to me, like, repetition is the mastery, right? What is the key to all mastery? I keep forgetting that saying there. So we need to go to interface gig 0/1, and his IP address is 10.1.100.1/24.0. Now we can no shut that bad boy, right? Think no shut. I think that's correct. I think that's right so far. I think that's right so far for this guy. So we get that IP address, we give him that IP address, and we got to do this IP address. Now let's go to router 2 and do these, and let's pay attention to the loopback number as well as what networks they're in. That's what I need to pay attention to. Let's verify our work, right? Show IP protocols. No, show protocols. Pete's favorite command over there. Show protocolo. Right there, 10, so interface gig 00. So that is this right here. He should be 10.1.200.1, right? 10.1.200.1. That's the network he is in, right? And then we have this guy, gig 01, which is that right there. I know it says serial, but I have a gigabit interface there. I don't have serial interfaces on my even G here. He is 10.1.100.1. And then we gave loopback 10.111, this guy right here. Loopback 1. Right? And we made him loopback 1. Next guy's got to be loopback 2. So that's something I need to be paying attention to more. Just little simple stuff like that. So, you got any questions so far or whatever? Let me know. And for anybody that's like kind of new to this stuff, like now you're getting all the basic homework first, like changing the host name and putting the IP address in before we get to more like complex stuff like the multi-area OSPF. Today we're only doing single area, right? So let's go to enable mode, right? That puts it into user exec mode, right? No, privileged exec mode. And then you got to go to global config mode, right? With configure terminal. That's for anybody that's new here, right? We're going to do, I don't have a serial interface here, so I have a gigabit interface here, right? Because we don't work with CenturyLink. So he's interface GI 0/1. His IP address is 10.1.100.2, right? Yep. So 10.1.100.2. You see that? .2. And then /24 subnet mask .0. We're gonna no shut that bad boy, and then we'll work on this interface right here, gig 00. So interface, actually, yeah, interface gig 00. His IP address is 10.1.200.2 /24 subnet mask .0. No shut that bad boy. We'll do the loopback, and then we got to change the host name because I didn't do that yet. Interface loopback 2. IP address is 10.1.2.1 /24.0. And then let's get out of this and change the host name. Host name is R2, right? Let's check our work with show protocols. And then we have gig 00, which is that right there. He should be 10.100 or 10.1.200.2. Yep, 200.2. Y'all see that? 200.2. That's this guy right here. And then we have the next one, 10.100.2, which is the gig 0 interface, which is that right there, .2. And then finally the loopback is 10.1.2.1, right? Yeah, 10.1.2.1, loopback 2, right there. Y'all with me so far? Anybody lost or There's no such thing as a dumb question. P said show IP protocols will show dynamic routing like OSPF. Really? Show IP protocols. Yes, that's the difference. That is the difference, right? Exactly. So we do show IP protocols. We haven't done any routing protocols yet, but there's this NSF aware, which I believe is non-stop forwarding. Can't remember what that is, but we haven't gotten any routing protocols configured on here yet. We're going to do OSPF, and then you'll see it on here. That's the difference. The difference between my other favorite protocol or command, which is show protocols. This shows us the interface, whether it's up or not, right? Layer 1 and layer 2, or layer 2 and layer 3, and then also the IP address with the subnet mask, as opposed to show IP interface brief. We don't give you all of that. It gives you whether it's up and down and whether the IP address is assigned, but it does not give you the subnet mask. That's why I like show protocols over show IP interface brief, even though that's a really popular command, right? When you want to do some basic troubleshooting at first, right? So let's start. I think we're good with router 2. Let's go with router 3. And I think we'll finally move on to the next task, right? Because we're still on the first one. Enable global config mode. His host name is R3, capital R3. And let's start off with we only got 2 interfaces on this one. .3 and loopback 3, right? So interface gig 00, interface gig 00. His IP address is 10.1.200.3, subnet mask of /25 or 24 rather, .0, no shut, right? Y'all see that? 10.1.200.3. It says 0, but that's the network address, right? That's the network address. This is the actual IP address we're going to assign to that interface for anybody that's new, right? And then the loopback address, interface loopback 3. His IP address is 10.1.3.1/24. And I think we're finally done with the IP addressing. Let's verify our work. Show protocols. Verify, 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 like my boss always says. Verify, verify, verify. It's like, I'm going to be sitting there in my sleep, man. Shut up, man. 10.1.200.3, right? Yep, 10.1.200.3/24. Yep, and then finally the loopback, which is up. And I think we're good to go here. I think we're good to go. We can do a show IP route just to see what routes we have. They should just be connected and local routes so far, right? Yep, C, which lets us know it's a connected route. What is it connected to? The 10.1.3.0 network. Where's that at? That is this back here. That's this back here. It's not really an arbitrary network. It's just that the loopback sits in that network. That's why we are connected to this network, right? We got another. These L's means it's a local interface. It's locally configured on here, 10.1.3.1. What is that? That is loopback, right? And then the C means we're connected to the 10.1.200 network, which is what? This right here. This is the 10.1.200 network that sits in between that. And then finally, this is the other network, 10.1.200. No, we said that already. The local interface of 10.1.200.3, which is this right here. That interface sits in that network, right? Y'all with me so far? What was the next task? Lab details. So we did the IP addressing and loopbacks. Finally, OSPF. What we came to do, right? OSPF stands for what? Open shortest path. Say that 5 times in a row. Open shortest path first. Who the fuck came up with that, man? It's basically, like we said, it's an algorithm that routers use to share routes with other routers, right? So if this router doesn't know how to get to a network that's back here, then he only knows about connected routes that are directly connected to him, right? So he's directly connected to this network. He don't know what's sitting back here unless one of these other routers share it with him. How would they do that? They would advertise it using a routing protocol such as RIP or BGP or what we came to do today, OSPF. It is a routing protocol. It's a dynamic routing protocol, which means, it's dynamic in its link state. So it changes routes when there's a downlink. So if we have a link that goes down over here and it says, and then it does these recalculation and it finds another fastest route. That's why they call it open shortest path first. This one's closed, so this one is open. This is the fastest way. And like we said the other day, it uses algorithm called SPF, which stands for shortest path first. And it's the same algorithm that they use on GPS devices and on your phone and stuff like that. And Google Maps or whatever. So what we're going to do here is, what did they say? They said, configure single area OSPF. See, I didn't write down all the steps, but they want us to do OSPF and make them all become neighbors. This is what we're going to do. we're going to use, let me see how they did it. Let's see. We could use a network statement that's going to advertise all networks, right? Like we did yesterday, where we did all zeros and then 255s, and then it advertises all the networks, right? We can do that. Or we can advertise individual networks. So we can advertise this network right here, this network right here, and that network right there, because these guys don't know about those networks. They sit somewhere back there somewhere. So like, for example, router 3 does not know about that network because it sits back here somewhere. It is not physically connected to him, right? These are loopbacks. They're virtual. So we need to have those guys advertise their loopbacks too. So isn't that where they're, oh, that's the next step actually. So let's go ahead and just configure a single area OSPF and advertise which networks. Let's see. Not the loopbacks. I don't want the loopbacks. Not yet. 10.1.2. How we want to do this? Because there's a couple ways we can do this. Let's do this. I'm gonna have him share that route with everybody. That network. So let's start off with router 1 and start off with that one. So router 1, where you at? Where you at? Y'all hit me that like button too. Configure a terminal, right? So we're gonna say router OSPF, right? And then you can put the process number. It can be any number between 1 through 6,500. 535, right? And they don't have to match, right? So he can be in process. He can have process 1. He can have process 500, and he can have process 100. We'll do that too, even. Yeah, let's go ahead and do that. He'll be process 100, right? Let's advertise the 10.1.100 network. Yeah, let's do that. 10.1.100.0. And then we got to put a wildcard mask, right? So remember, the wildcard mask is like the opposite of a subnet mask. So the subnet mask is /24, right? Which is what? 255.255.255.0, right? But we're not going to do that. We're with the wildcard mask. So it's the reverse of this. So what is that? Backspace. 0.0.0.255, meaning we only care about that last octet. Then you got to put the area. In this case, we're going to do area, what they said. They said area 0. Right there. So all these guys are in area, one area, and that's the backbone area, area 0, right? Once we start going into more advanced stuff, we'll be doing multi-area OSPF, which means like this is area 0, right? Then we'll have like area, I don't know, area 2 right here, right? And then we can have what? Area 54 right here, right? Just like the governmental agency or whatever, governmental property, right? Area 54 or whatever it is, right? Now we got Mickey Mouse right here, and then we can give him a net and then make him area 5 right here, right? And now we have multi areas, and they all connect. They have to all connect to the backbone. It's just that when you're designing an OSPF network, you got to start off with the backbone, which is area 0, and that's what we're doing today, right? So very similar to what we did yesterday. Is just kind of different, and different topology, really. So area 0. Let's go ahead and I guess do the same thing here. Put that same network statement to make them OSPF neighbors, right? So we'll just copy this statement, and then we'll advertise the loopbacks as they said in the other step, other task, right? So global config mode. We'll do router. I know we said router 100 here, router OSPF 100 here. Let's do router 200. OSPF 200, just to prove that it don't have to match, right? Watch it crash because, or this shit don't work because it don't match, right? The OSPF 200, right? And then I thought I copied and pasted. Apparently I didn't. Bloop. Bloop. Make sure you subscribe to your boy too, man. We typically stream Monday through Thursday, 8 p.m. Eastern Standard Time, right? Sometimes I'll cancel, or sometimes I'll do bonus stream, whatever. It looks like my thing is freezing up over here. Dope stream. Where can I find the lab instructions? I got this from actually an super old book. It was a CCNP lab manual back in the day, when they used to have like route exam and switch exam and stuff like that. So I just took those and then kind of like made my own lab and stuff like that, and just to kind of demonstrate OSPF and just to kind of explain it and stuff like that. If you want, I can copy and paste the. That's a good question too, Juan. Or phase 114 rather. I'll copy and paste this, and then just join the Discord server, and you should see it in the Discord server. And if you want, you can copy and paste that if you want to, right? So make sure you join the Discord server. I will give you a invite to the Discord. That is the invite to the Discord. If you want a copy of that, and then maybe I'll copy the topology just so you guys can have it as well. If you want to like practice this on your own or whatever, right? So we did the IP addressing and loopbacks. We did the single area OSPF, but we didn't make them neighbors yet. So let's go ahead and do that. I think they should become neighbors after a couple of minutes here, right? Let's see. There we go. We got an adjacency on process number 100 from router 1. So that's from router 1's vantage point. Let's go to router 2 and see what he sees. He says, yes, I have a router adjacency, and it's on using process 200. So see, notice that this guy is on using process 100, and this guy's using process 200, right? Yet they still became neighbors. So he is using 100, and he is using process number 200. Just to show y'all that it ain't got a match. It's EIGRP. That last number got a match. That last number is actually known as not a process ID, but it's an autonomous system, and that's a totally different concept. Once we get the EIGRP, we'll get into that. But just for now, remember the process ID for OSPF does not have to match. Let's go ahead and make, so these guys are neighbors, right? Howdy doody. Let's go ahead and make these two guys neighbors, right? Yeah, let's go ahead and make them two guys neighbors. We are going to use that right there. And then actually, he probably needs another network statement so that way he can be neighbors with him, right? So that way we'll have full adjacency, like full adjacency on all the networks and stuff like that, right? So let's go to router 2 and do one more network statement. We got to do a network statement that puts our interface, this interface, to participate in OSPF, right? So we got to go to, we can use the same process ID. We're just going to put another network statement, right? So in this case, 10.1.200, right? 10.1.200.0. And then remember, not the subnet mask, but the wildcard mask, which is the reverse of a subnet mask, right? And then area 0. We can go ahead and copy and paste this bad boy, put it into the other router. So router 3, this guy right here. So go to router 3. And I fucked up my clipboard already, so let's go ahead and copy and paste that again. And let's put him in router process ID 300, right? Right, so we'll say router OSPF 300. We put that network statement in. Get on our knees, pray to the network gods, and hope them two become neighbors. Pop quiz. How often does OSPF say hello to its neighbors? How often, by default, does it say hello to its neighbors? First one that answers it gets a free bruh. And it don't look. Oh, you know what? I got on my knees to pray to the network guys. If you want to also answer this, why didn't they become neighbors? Why didn't they become neighbors? Even though I put the network statement there. Why did they not become neighbors? These two right here. Bloop, bloop. We didn't become neighbors yet. While y'all figure that out, let's put another network statement over here. And put 10.100 to that one right there. We'll put that. There it is. It became neighbors now with somebody else. 2.1. Okay, so he became neighbors over here. It should be the same neighbor, though. It should be the same neighbor. Let's see. Even though we don't got another network statement. Let's see. Process 300. Router 3. Oh, there you go. I see what happened there. 10.1.300. 10.1.3. 10.1.3. What network is that? Okay, they did become neighbors, I believe. 10.1.3.1. Okay, yeah, so they became neighbors now. I was gonna say I thought I didn't put the network statement there. I did. I'm just like talking ahead of myself right there. So they did become neighbors. My bad. Morningstar got it correct. Actually, Zaya, y'all all got it correct. Damn, y'all just on the roll today. Yes, Zaya got it correct. Pete S got it correct. Morningstar got it correct, and also Diane Foster. Y'all all got it correct. That's right. OSPF says hello every 10 seconds, and then by default, it considers its neighbor dead, which is also known as the dead timer, 4 times the hello, which is what? 10 times 4 is what? 40. So it considers its neighbor dead after 40 seconds by default. We could change these timers now. We could change it to make it say like we did yesterday. We changed the timer to say, I believe, 5 seconds. Say hello every 5 seconds, if I remember correctly. I can't remember what we did. But now they became neighbors. Let's see. Let's take our neighbors out. Show IP. So now we're just going to kind of go around the neighborhood and give out some fruit cake and see who we got as a neighbor. Router 3 only has one neighbor. It's 10.1.2.1. Who is that? That's this guy right here. He did not become a neighbor with this guy yet. So we need to advertise what network? 10.1.200. We did that. We need to do, he needs the 10.1.200 to become another neighbor. Router 2 probably has two neighbors. Let's see how many neighbors he got. Show IP OSPF neighbor. And yes, correct. He has two neighbors, 10.1.3.1, which is what? This guy, and 10.1.1.1, which is what? This guy. So router 1 probably has just one neighbor, and that's probably router 2, which is 10.1.2.1. If that serves me correctly, show IP OSPF neighbor 10.1.2.1. Yes, it is. So he only got one neighbor. He needs to actually have two neighbors, which is, let me get all this third grade scribble out of the way. Right? He actually needs two neighbors. He needs that guy's neighbor, and he needs this guy's neighbor. Right? Y'all with me so far? Y'all let me know if y'all lost, whatever. Like, don't be afraid to ask any questions and stuff like that. There's no such thing as a dumb question. There's a lot of smart people in that chat room over there. Silas said it depends on the network type. When he said depends on the network type, what was I talking about? I can't remember because I had to look back in the chat for that one. We need one more network statement for these two guys to become neighbors. These two right here. Bloop, bloop, bloop. What network statement is that going to be? It's going to be this right here, 10.1.200. So we got to go to global config mode, and we say router. What was the process ID? It was process ID 100 on this guy, right? Yeah, OSPF 100. We're going to give it one more network statement. That's 10.1.200.0. Subnet mask of 000.255, and then area 0, right? And then give it 10 seconds, right? 3, 4. Oh, I guess it came up already because the other one probably said hello already. But so there you go. Now he got two neighbors. So now on process ID 100. So now we can do a show IP OSPF neighbor. And he should theoretically have two neighbors. No, he got three neighbors. Interesting. Probably because you know what? He is a neighbor with this guy using two networks. That's why. So he is a neighbor with router 2 using this network and that network. That's why it looks like he's got two neighbors there. So, and the way this is designed. So basically, he got two ways to get to this router, like we mentioned before. We're going to change the cost so we can show how we can engineer our traffic, like a real network engineer would do, right? So, PS said timers and OSPF network types. Oh yes, that's true. Silas is correct. That is very true. That is a very, very good point. Shit, forgot about that. It depends on the network type as far as the timers go. But I think on which network type? What's the network for the route between router 1 and router 3? Good question. I need to go back and track. So you said, to answer Morningstar's question real quick first, router 1 and router 3. She wanted to know what the network is between the two. The network between the two is this right here. The 10.1.200 network is between those two networks. That's where they sit in. That's how they became neighbors, because that's how, once I put in that network statement, that's how they became neighbors. You see that? And then your other question, or not other question, but Silas made a really good point. The default timers are 10 seconds for hello, 40 seconds for a dead timer, but it also depends on the network type. So on a point-to-point network, I believe, so like in this case right here, well, that's not a point-to-point network because they're all going to be network. They're all going to be broadcast. They are different timers for those. But as far as the default timers, OSPF timers, we were talking about in a, broadcast network, right? Correct me if I'm wrong. So anyway, let's, what was the next task? Next task. And if you want a copy of these tasks or whatever, just join the Discord server and you'll see it. I copied and pasted it. You just probably have to put the numbers in because they didn't copy the numbers in. So, we configured single area OSPF. Let's go ahead and advertise the loopback interfaces, right? So we got loopback 1, 2, and 3, right? We need to advertise those networks. So why do we need to do that? Well, because, for example, router 3, he know how to get to this network. Bloop, bloop. This network right here, because it's directly connected to him. And he know how to get to that network, probably because it's broadcasted to him by router 1. Let's see. Does he know how to get to the 10, 100? Just to prove my point, right? So let's go to Route 3 and see if he knows how to get there. Most likely he does because he's OSPF neighbor. So we just do show IP route. Do you know how to get to the 10, 1, 100 network, router 3? Yes, you do. How did you learn it? Through OSPF. That's how he learned about that route. Well, we need to do the same thing about these networks right here because these are virtual networks that sit on the router and they don't know about each other, right? So router 3 doesn't know about the 10.111 network. Is it on there? Do you see it on there? No, it's not. So because router 1 needs to advertise it to let them know about it. Router 2 and router 3, right? So let's have router 1 advertise his loopback. We'll go to global config mode and say router, we'll use the same network statement, right? OSPF 100. And I'm glad I used those numbers instead of some random ass numbers so that way I can remember these processes IDs or processes, right? We're going to use the network statement of 10.111 and then /24. So it's going to be 10.1.1.0. And then we'll say, we could just do 1, right? And do it like that. And then say 000.255, right? Because I think you can do it that way. And then say area 0. Now router 3 should theoretically know about that, right? Now he only had 1 OSPF route. And I think maybe, I don't know if I got to clear the process to see that or not. Let's see. He knows about 1 OSPF route, the 10.1.100. Does he know about the 10.111 network now? Get underneath, pray to network gods. And yes, he does. Right there. See, now he know about the 10.111 network. How? Why? Because now router 1 told him about it. He said, hey, y'all want to know how to get to the 10.111 network? This is how you do it. And he shared it by speaking in his own language. What's that language called? OSPF. Okay, gotcha. Aaron said, should we make router 1 to router 2 a point-to-point network to represent the serial connection? Very, very good point, Aaron. We should do that. We should do that. He's talking about this right here. This network right here, we should make this a point-to-point network just to see. And I think the timers will be different for that if we do that also. I don't remember. And what do we have to do that? I think you got to go to interface. That's an interface level command, right? Correct me if I'm wrong. Well, we'll do that in a second. Silas said 1040 for broadcast and then 1040 for a point-to-point. So that's the same timers then. Oh, okay. And then point to multi-point is 30 and 120. Gotcha. Y'all see that? So even though, remember I was talking about the default timers, right? Silas made a good point. If there's a different type of network, the timers will be different, right? So this right here on the map is a point-to-point network. Point-to-point. Why is that point-to-point? Because it's point to point. There's only one, there's only 2 routers in this network right here, right? This right here, this is a broadcast network. We've got this router that sits in it. We got this router that sits in that network. This guy, I don't even know what the hell I'm doing here. This guy that sits in that network right here. Well, let's do this. He sits in that network, and he also sits in that network. This is known as a broadcast network, or sometimes they call it what, NMBA or some shit like that. I can't remember. NBMA, non-broadcast or broadcast network. I don't remember. But this is a broadcast network, and then that's a point-to-point network. The timers are going to be different on all of these guys. Let's verify what we got so far. Let's go to router 3 and see what he has. Show IP interface. Show IP OSPF interface. We'll do GI00 and see what the timers are for this one, right? Timers are hello 10, dead 40, wait 40. So all default, right? Why is that? Because this is a broadcast network. Just like I said, if we change the network type, these timers will change, just like Silas said. So very good point. Very, 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 very good point. Morningstar said, oh, make it a flat /30 instead of a 24. We could do that, but that would break it. Well, not break it, but it would be kind of like veering off the network here. We could also just change the network type, believe it or not, Morningstar, instead of changing the subnet and all of that. And I forgot how to do that. Let's see if I remember how to do that. Let's see. Y'all remember how to do that? Y'all let me know if y'all remember how to do that. Let me see. I think to change the network type, I think you just go to the interface and say what it is. IP, oh, that's what it is. That's what it is. And that's actually what they want us to do for the loopbacks. But I didn't put that in the, did I put that in here? No, I didn't do that. I didn't do that. Let's do this. I'm jumping all over the goddamn place. Let's broadcast this network right here, the loopback, and then broadcast this network, the other loopback. So let's do that before I forget, right? Because that's where we were at. We are doing advertise loopback interfaces into OSPF, and then we'll move on to the suggestions you guys made. So router 2, where's he at? He needs to broadcast that network. Go to config mode, and just to show y'all, right? So nobody knows about the what network? 10.1.2.1 network, right? Does router 3, does he know about the 10? Does he know about this network right here? Right? Does he know about it? 10.1.2.1 network. Let's go to router 3, right? Show IP routes 10.1.2.1. We got 10.1.1, 10.1.3, 10.1.3.1. No, he doesn't know about it. He does not know about it. How can we do it? Advertise the network. Go to router 2, router OSPF, what, 200? I hope that was 200. I hope that was 200. Yes, it was. It's 200, right? Otherwise, we'll make another process, right? Network 10.1.2.1. We'll just do, yeah, 1. And I think it'll change it. It'll change the network statement, wouldn't it? 000. I need to see. 255 area 0. That should advertise it. So now he knew about what? How many networks? OSPF networks did he learn? He learned 1. He learned 2. So he should have theoretically a third OSPF route. Get on the knees, pray to the network gods, and he got 1, 2, 3 routes that he learned about. You see that? You see how I did that? All right, good. So now we need to advertise this loopback to these guys right here. This guy and this guy doesn't know about that network right there. I'm sorry. Real quick. This network right here. This guy doesn't know about it. With my broken and this guy does not know about this network right here. We need to advertise it using OSPF. Same concept. Configure terminal, router OSPF. He's what, 300? We said network 10.1.3.1 000.255 area 0, right? And then router 1 should know about the 10.1.3.1 network now, right? Let's see. And it should say through loopback 3, right? Show IP routes. Does he know about it? 10.1.3.1 network? Yes, now he know about it. So now he got all those OSPF routes. So we good to go there so far. Brooklyn 2K1, appreciate you for tuning in. He said that would make sense since it's point-to-point /30. Yes, you're right. But like I said, I don't want to just like change the lab just to do that. We could also change the network type. But yes, you're right. It would make sense to make it, if it's a point-to-point network, use a /30 subnet because you only have 2 usable hosts. You're right about that. But I'm just going to change the network type, and then we'll, play with the see if that changes the timers and play with it and stuff like that, right? So next thing we want to do is, matter of fact, let's do this. Morningstar said understood. But if it was in fact a serial connection, it would have to be /30. Not necessarily, but it would make sense to make it /30. Yes, it would make sense. Even like in production networks today, that is the most logical way to do it. /30 subnet, and then one guy's going to be .1 or whatever, and the other guy is .2, or one guy's going to be .2, .3, and then the next network is .4, right? I believe something like that. No, that's the broadcast. The next network would be .5. So, but yes, yeah, you made a good point there. What was the next task? We advertised the loopbacks. Verify the OSPF adjacencies, which we've already done with what? Show IP OSPF neighbors, show IP OSPF neighbors, right? We see he's got 3 neighbors. He's actually got 2 neighbors. It's just that he learned about the other router through 2 interfaces, or 2 other networks through the same interface there. Verify OSPF routing information exchange. Over here, sounding discombobulated and stuff. We could do that with show IP protocols, I believe. Show IP protocols, routing information exchange. That's the information sources. Not too sure exactly what they mean by that. But we can see these are the networks that we are routing for. That's our network statements, essentially. And then who our sources are, 10.121 is who? That's this guy right here. And our other source, it's like, you might as well say that's the neighbors that came into our neighborhood. And that's their router IDs, right? Default is 110 for the administrative distance. What does they want to know here? Because these ain't really, this is like show commands, verify, verify. But I guess, I don't know, would my boss write this? Verify, verify, verify. Modify OSPF links on all gig 00 interfaces to a cost of 50. All right, so what are the costs now? Right now, we could just do, let's find out the cost of this right here and find out the cost of this. They're probably going to be the same because they're both gigabit interfaces, right? Show IP. Y'all hit me that like button, man. And make sure you subscribe. Where we at? We normally tune or stream Monday through Thursday, 8 p.m. Eastern Standard Time. I may cancel tomorrow because I think I'm gonna have my daughter tomorrow. She got swimming practice, so she's staying with me. And I like to spend time with her and stuff. What was the next thing I was gonna do? Shit, over here. Modify link costs. That's what we needed to do. Show IP interface gig 00, and we just say no. Let's do this. Show IP OSPF interface gig 00. That should give us the cost. The cost is what? 1 to get there. They said to go ahead and change all gigabit interfaces to a cost of 50. So right now, to get to, and I see why they're gonna make it so that way this is the way we get to that network right there. What interface? What way does he take to get to that interface there? This is similar to yesterday's lab, how we changed the cost and manipulated the way it's gonna go and stuff. What I wanted to do, they want me to change the cost, but let me see what the cost is. Right now, the cost is 1. How do we find out the cost to? Let's just look at our routing table. To get to the 10.121 network, right? To get to 10.121 network, our cost is 10.121 is 2, right? Even though it says cost is 1, that's the metric actually. I don't think that's the cost. That's the metric. Metric is 2. Now let's change to get to 121. We got 2 ways to get there. We can go this way or that way. That way, float on the track like a Segway. Let's change this cost to what we said, 50 over here. And then we'll change the cost to 50 over here. I can't remember what this was supposed to demonstrate, but we could change the cost and then basically change, manipulate traffic just like we did yesterday's stream, right? So let's go to gig 00, change the cost on that one. I think it's interface level command, right? So we say interface GI00 and then IP OSPF cost. And then they said to change it to 50. See what happens with that, right? We change the cost to 50. I don't remember. I believe we got to bounce the OSPF process to see that change. Right now, the cost is 1. If we do this command again and see what it is, if it still says 1, cost is 50 there. So we did not have to bounce it. Broadcast. Let's make this a point-to-point network, like y'all was saying. And they also wanted this too. I should have put that in there. They wanted the loopbacks to be point-to-point networks. Phase 114 said, we need NetworkBruh wave caps, bro. I'll be first customer. Man, first of all, this is a bonnet. Yeah, but I probably should do some wave caps, right? Because I'm always wearing wave caps, but I haven't been rocking the waves. I'm growing my hair out. So, yeah, I'm doing the bonnet thing right now. Metric of OSPF is cost. Oh, so yeah, so then essentially that is the cost, right? I said, well, that's the metric. So yes, good point, Aaron. What he was saying is this right here, the metric is cost. So the metric in this case is 2. Administrative distance is 110. What do we want to do though? Change the costs to 50 on all of them. Don't remember why they wanted that though, because I didn't really. I'm gonna start putting these labs together ahead of time, so that way. Router 2, let's go to that interface, gig 00, and do the same thing, right? So interface gig 00, IP OSPF cost 50. Do the same thing on that gig 00. No, I did it over here. Now I need to do it over router 3. Interface gig 00, IP OSPF cost 50. And then I guess to get to that one network that was up there. So in other words, he was probably taking this way to get to that network. Now he'll probably have to go this way. But I didn't even break down. Let's see. What does this routing table look like now? Show IP route. Cost is 50 to get to. So now to get to the 10.121 network, he's going to use 10.100.1.2. So yeah, that's what it is. Instead of going this way to get to that network, now he's going this way. That's why that network is on top. See that? Because the cost is now 2. Now, I didn't really change. I changed the cost here, but there's only like one way to. Well, let me see. He could have took this way, or he could have took that way. Because that's what it is. So now, if he wants to go, let's see. Let's look at all their routing tables and see what it did when we do that. Show IP Ospf. Route. We'll see. We changed. There was only one way to get there anyway, right? See, to get to the 10.131 network. So now the cost to get there is 50 instead of it was 1 or 2 rather. It was 2 last time. So I didn't break down what exactly that was supposed to demonstrate. So we'll go ahead and, well, we didn't skip it. We went ahead and did it. Now they want us to modify interface priorities to control the DR and BDR election. How we do that? We're going to change the interface priority on router 1 to a priority of 10. Let's see what they are first. And then change the interface priority on router 2 to priority of 5. Let's see who the DR and the BDR is first, right? You remember what that is, right? DR is the designated router. He is not the guy that's going to drive us home when we're drunk. He's the designated router. He's the router that keeps like what's called the link state database. All the link state advertisements and stuff like that. Everybody needs to sync to him, their database, to make sure that they have all the routes and stuff like that to him, the designated router. Who is it on this network? Let's see. Let's go to router 1 and find out. Show IP, I believe it's Ospf database to find that. No. To find out the backup designated router and the designated router, I think you could just do the interface, right? Show IP Ospf by itself. Designated router and backup designated router. Nope, I think you got to go to the interface to do it, right? Y'all let me know. Y'all remember. Y'all remind me. That's what y'all here for. Metric. Oh yeah, you said that right. Oh, I thought that's because bruh was making sandwiches before stream. I look like a chef or something, right? Nah, man. I'm just beneath it. So, to get the backup designated, I believe you got to go to the interface and do it. Let's see. Show IP Ospf. We did this yesterday, didn't we? GI00. We see the designated router is this guy. Designated router is 10.131. Who is that? 10.131 is this guy. So he is the designated router on this network. What is that? That is a broadcast network. And we're gonna make this a point-to-point network. I know y'all waiting on that one right there. Oh, we needed to put the loopbacks too. I'm gonna change these steps here. So we have a designated router. He's 10.131. The backup designated router is 10.121. Who is that? That is this guy. So he is the designated router. That is who everybody gets their. This guy is a backup designated router. So he's the BDR. Pop quiz. If he is the DR, this guy right here, and he is the BDR, what am I? What am I? Well, y'all figure that out. The next step was to go ahead and change the interface priority on router 1 to a priority of 10, and then the interface priority on router 2 to a priority 5. This is going to modify the interface priorities. We're going to control the DR and BDR election. So now we're going to change who is the DR and who is the BDR, right? Backup designated router, I guess I didn't explain that one. That one is basically, he's the backup. So when the designated router goes down, right, somebody like my daughter walks into the data center and throws water onto that router, the designated router, right? Bloop. Then he, over here, will turn up. He will become the designated router because this one went down, right? Silas said the database can tell you, LSA2. Oh, the database can tell us who is the, you're saying who is the designated router and backup designated router? Did I do that? Oh, okay. I see what you're saying. So I do show IP OSPF database, and that tells us who is the designated router or who is the backup designated router. You said the LSA number 2. So I believe this is LSA 2. This lets us know who is the designated router, who's the backup designated router. Where does that indicate that though? Because you're right. Let me see. 10.121 and 10.131. No, he says 131 is the designated and 121 is the backup designated. So this is link state. No, this is a type 2 advertisement. This is a type 1 advertisement. Show me where you're saying that the database can tell us who is the designated router and who's the backup designated router. So that was the other pop quiz too. Since this guy is the backup designated router and he is the designated router, what does that make him? What does that make him? I'm still waiting on y'all. Waiting on y'all to answer that one. We almost done here, y'all. We're on task number. What task? We're almost done. What task are we on? 7 and 8. We need to change those priorities, and then they just want us to utilize some debugging commands to kind of troubleshoot OSPF. I guess we could break stuff and then look at it real quick by running some debug commands and stuff. Netlink. You saying the netlink? Okay, so that's it right there. This is the type 2. This is a type 2 netlink. That's how I need to remember that. So this is a type 1 LSA. This is a type 2 LSA. But how does this let us know who is the backup router and who is the backup designated router and who is the designated router? Because when we did show IP OSPF and then the interface of that network, that tells us exactly who is the designated and who's the backup designated. Morningstar said router 1 is a BDR 2. Not quite Morningstar. Aaron Lewis got it correct though. DROTHER, also known as a DROTHER, if you want to pronounce it that way. So when you are not a BDR like this guy, and you are not a designated router like this guy, in the broadcast network, if we're not neither of those, we are known as a DROTHER or DROTHER, as Aaron Lewis said. So not quite phase 114 or Morningstar. So it's when you're not a DR or a BDR, you are a DROTHER, right? Who the hell came up with that name? So you're a DROTHER. So you're just kind of like you participating in. You're not even really participating. You just becoming adjacent with the. You're becoming fully adjacent with the designated router, and then you will be in a what state? A two-way state with the BDR. So you will become full with this guy, but you will stay in a two-way state with this guy when you are a DROTHER. This guy right here, right? So I forgot where we could see that too. There's another way we could see who are we two-way with and who are we full with. I think with the neighbors, right? Show IP OSPF neighbor. No, he is full actually with all of them. Interesting. I thought it was two-way. I thought it would have been two-way. Y'all let me know why it don't say two-way there. I thought it would have been two-way and not full. But either way, he is the designated router. Oh, he's the designated router. He's the backup designated router. And I am the DROTHER. I don't know. I gotta look into that. We changed the cost. Let's see. Simon said, a lot to explain about OSPF. LSAs, that's a whole, yeah, tell me about it. Like I said the other day, there's 11 types of LSAs. With this right here, we only look at only 2 of them, right? That command right there, the show IP OSPF database, that's a type 1 LSA, that's a type 2 LSA. There's actually 11 types, like we mentioned yesterday. And it's a really, really super deep subject. Like OSPF can be really complicated, as you can see. I thought I was talking. I could have sworn that would have been only in two-way state. That's weird. Let me look at router 2 real quick, just to see. Can I get my points back? It's all good. Hey, that's what the discussion is about, man. So show IP OSPF neighbor. There he is. He is a DROTHER, like we mentioned. So 10.111 is a DROTHER, and he is in full state with him. But I thought it would have been two-way. So that's what I'm confused about. I need to double check that. For real. What was the other thing we were going to do? We were going to change the priorities and then call it a night, right? So we only got 3 more steps. change the interface priority on router 1 to priority of 10. They didn't say which one, so we'll do interface 00 on both of those interfaces. So we'll go to router 1. He said two-way state between two DROTHERs. I think you're right. I think you're right, Aaron. So if we had, I think Aaron's correct. So if we had another router, if I drag and dropped another router, I don't know, like right over here, he's going to be router 4, right? He's router 4 over here, and we have a connection to him, router connection to him. So he'll be in a full state with him. He'll be a full state with him because he's the backup designated router, and he's a designated router, and this guy's a DROTHER, and this guy is a DROTHER. Then I believe these two will be only in a two-way state. I think you're correct on that one, Aaron. I think you're right. I'll have to double check that tonight, and I'll let y'all know on the Discord server. So make sure you're joining the Discord server, so that way I don't steer y'all wrong and stuff like that. Y'all know I don't know everything, so that is the link to the Discord server. Morningstar said, it's not in a DROTHER state because router 2 is a BDR. Yes, correct. Just like I said. So router 2 is a BDR. Router 3 is the DR. So router 1 is the DROTHER or DR other, however you want to pronounce it, right? Tomato, tomato. Let's go ahead and finally change those interface priorities. I know somebody over there waiting in the stream like, will you change the goddamn priority so we can call it a night? Router 1, interface gig 00. Interface gig 00. So once we do this, we're going to change. This is kind of like, a presidential election here, right? We said you're going to be the designated router. You kind of like the president, right? And we said he is the backup designated router. Right? And we're going to be kind of like, we trying to do a coup d'etat over here. And we want to make him, he is a DROTHER right now. We want to make somebody else a designated router. Like, we don't like this shit right over here, right? Now, I'm not going to get into any politics in here right now. So let's, the way we do that is, I believe, OSPF priority, and then you change the priority number. What is, and I believe you got to go to the interface. Yeah, we go in the interface. Where is, what was I going to do? Oh, we got to go to the tasks here and see what we wanted to do there. We wanted to modify the OSPF link costs. We did that. So we need to change router 1's priority to a priority of 10. Priority of 10. So go to router 1. So IP OSPF, right? You cross your mark, you'll see all the OSPF. Remember last time we was doing the process ID. We was doing the cost. We want to change now the priority. I believe, yeah, the cost will change, manipulate the routes and stuff like that. When we change the priority, we're changing who is going to be, well, I believe it's the higher the priority. Is it the higher the priority, the more likely you are to become a, well, it depends on whose vantage point you're looking at it. But whoever has the lowest priority, I can't even remember. If it's lowest priority or highest priority, that will determine who is the DR and a BDR and stuff like that. But remember, last time it was he's DR, he's BDR, and he was a DROTHER. Once we change all of this up, we're gonna shake up the whole economy here, right? So IP OSPF priority, and this could be a number from 0 to 255. They said to go ahead and change it to a priority of 10 on router 1, so 10. And then on router 2, we want to change it to priority of 5. So we're gonna go to router 2. And I believe we might have to bounce the OSPF process to see this too. PSA, yes, that's correct. Oh, and he gave us a white paper too, man. Shout out to Pete for that one, man. This is why you're a moderator, man. So we got a white paper that'll let us know the neighbor states and stuff, right? So at the end of this stage, so we only become two-way with what, DROTHERs? Can't remember. So in broadcast networks, a router becomes full with DR and BDR. It stays two-way with other neighbors. Okay, good. Just like I was explaining. Okay, good. Appreciate that. Highest priority in OSPF. So yes, it's the highest priority. And this is why I fuck with y'all. This is why I like streaming with y'all, because sometimes like some of this stuff I don't remember. and I look over y'all give me right. Okay, yeah, I remember. And believe it or not, I go back and watch these streams and listen to them in my car and stuff like that. I just put the high speed so that way I can listen to it before I get to work and stuff like that. So it helps me remember a lot of this stuff, right? So we're gonna go to interface gig 00, and we said to change it to priority of 5 on that interface. IP OSPF priority 5, and then we're going to do some debugging commands and call it a night. And now that we've done that, let's see who is the DROTHER and who is the BDR and all this other stuff, and we'll find out. I think we got to bounce the OSPF process though. I know I said that a million times, but let's see. Show IP OSPF interface gig 00, and it says here I am a BDR. Right, so router 2 is a BDR. He was a BDR already anyway, right? And then we said the designated router was 10131, who was this guy. So that didn't change. That didn't change just yet. I think what we need to do is clear the process, right? So let's go back to him and see what his was. We'll say show IP OSPF interface gig 00, and if not, then we'll just 121 is the backup. So yeah, he's still nothing changed yet. So let's do this. Let's bounce the process on all 3 routers and let's see what happens. If not, we'll change the cost again because I don't remember interface gig. No, we'll say we get out of this clear. When you can either reboot or clear the process, it's probably easier to do the clear process, right? So clear IP OSPF process. You can put the number here as well. No, you can do the number. You can do one process if you want to at a time like that. Clear IP OSPF and then process number. So in this case, 1. And then process, right? What you mean? Oh, because it's not 1, it's 100, right? On this guy. I'm like, what are you talking about? Process. There. Now you do it, right? You can do that way. That resets the process. Down, come up, bounce that ass. Go to router 2. Do the same thing. Actually, we might have. I don't think we got to do on all 3. Let's just see. From router 1's vantage point, what does he got now? Who is he saying is the BDR? Did anything change? We'll do show IP, what was it? OSPF gig 00. So now 10121 is the backup. That's still the same. So yeah, it's still the same. So let's do this. Let's bounce the process on this guy and that guy. But it already did. So I don't think we got to do all 3. If not, we'll change the cost again, then call it night. Clear IP OSPF process. That'll do all of them. Yes. Do the same thing on this guy. Enable clear IP OSPF process. Yes. Reset the process. Bounce that ass. Go to router 1. I want to become the designated router, right? No. 10121 is still the backup. He's still the backup. I think he's still coming up. Is he? Let's see. Down, detached, loading full. Who is the... So 121 is the backup. So he is the backup. So that means probably router 1 is now the DR. So I am the DR. So basically this is what we did. He's still the backup. This guy's still the backup. But now he is no longer the DR. And now he is the designated router. So now he is the designated router. And this guy is theoretically a what? A DROTHER or DROTHER. DR other, however you want to pronounce it, right? And we can verify that with what? We go to router 3 and then show IP OSPF interface gig 00, and we'll see he is a DROTHER, right? Good to go. We can just do some debugging commands. Y'all want to do some debugging commands? Utilize debugging commands. What they want us to do? We can do debug IP OSPF adjacency, something like that. And then you can see the process of, remember what the white paper that I sent y'all, the neighbor states, the 2-way. As a matter of fact, the paper that Pete S put in the chat there, that gives you the neighbor states. You can see them going through the process of becoming a neighbor. It's just like you moving into a neighborhood, right? You see somebody move in with the U-Haul truck. You see them getting out of the car. You see them getting out of the truck. You see them unloading the furniture. You're like, oh, look, there go some neighbors. Let me go and see if they know how to speak OSPF. You walk up to them. You say hello, right, every 10 seconds. And then you're speaking to them. You speak OSPF? Oh, shit, we speak OSPF too. And then y'all started exchanging numbers. Yeah, I got this. I know this way to how to get to the convenience store. I know all these routes. Oh, word, I know all these routes too. And that's exactly what happens. We can see the entire process by running debugging commands, right? How you do that? Debug IP OSPF adjacency. We can do that. Or we could do, there's so many adjacency commands. I'm not going to go through all of them because there's just so many of them. Just like we said, the LSAs, there's 11 of them. We can see the generation of them. We can see, what else could we do? We do hellos. We can watch it, say hello every watch. We can do this. Watch this. Hello. We'll just do that. Let's just do that for now. And it will see, hopefully it ain't crashing right there. So we always process 300. We sent a hello. We received a hello. We received another hello from this guy, right? Every 10 seconds, right? So there go another one. That's every 10 seconds right there. We sent a hello right there. We received 2 more from the other 2 neighbors, right? We can do some more debugging here. What we can do here? We could do events, but that'll be a little too much. We can do packets. That'll like break it down. I'm not going to go through all of this because it's a lot. But this is a good way to troubleshoot whenever you have OS. Like, let's say you're like, damn, why isn't OSPF coming up? You can do this, like turn on the debugging for the hellos and see, okay, well, I'm sending some, but I'm not seeing any receive some. Let me go on the other router to find out, right? And there's just so many debugging commands you can do to troubleshoot this. I'm not going to go through all of them. So this, if y'all want to do this on your own, y'all go ahead and do that. But anyways, I typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. Go ahead and subscribe to your boy. Hit that like button. We are following this. I'm somewhat following this study plan right here, right? Because this lab right here, I kind of created on my own and just like got it from another old book, right? And just kind of like modified the steps just so I can explain single area OSPF and stuff like that. But anyways, this spreadsheet right here is a Google document. I took all of the the exam topics, put it in a spreadsheet, broke it down, and said where you can find topics. For example, access point, join, and the discovery and join process. We have some videos on it. You can find it on page 1107 of the Encore book. There's no labs because the 101 labs book, they don't do anything on wireless. None of this stuff. As a matter of fact, both on NetSim don't have anything on wireless. So that's why there's X's here. I've got several YouTube videos, some of which from some guy named NetworkBruh. He's pretty hot. We got some, let me see, stuff from both on NetSim. And like I mentioned before, once I get to 5,000 subscribers, I'll be gifting away a copy of that application so y'all can do it along with me with these on the live streams and stuff like that. So if you want to copy this spreadsheet, and you can modify this however you want. You can change this all up and be like, man, NetworkBruh don't know nothing he's talking about. Highlight all this shit, click delete, and make your own spreadsheet if you want to, right? But if you want a copy of it to make it your own, make sure you join my Discord server. Here is a link. Bloop, bloop. Oh, that's right. There's a couple things you wanted to do. Would we get fired if we reset the process during business hours? Pete, you trolling over there, man. I'm not even going to answer that question, but I see what you're trying to do here. I don't think you want to do that, right? You definitely want to do something like that. You put in a change request and do it after hours or something like that, or do it whenever nobody's on campus or whatever the case may be, right? So, there was one more thing we wanted to do, right? Even though it's not on the steps, we wanted to make a point-to-point network. We wanted to make this a point-to-point network and see the whatchamacallit change. Let's do that real quick. Let's stop this process, right? You all turn that off, right? So we turned off the debugging. Let's go to the interface GI01 and turn that to a point-to-point network, right? Because right now it is a what? 0/1 is a broadcast network, right? Even though there's only one network, 2 routers on this network. Let's make it a point-to-point. I believe you go to our interface, you say interface gig 0/1, you say IP OSPF what? Network? Yes. And you have these kind of networks here. You do broadcast, non-broadcast, point-to-multipoint, or point-to-point. Y'all wanted point-to-point, right? Because the timers are different. And not only that, this was supposed to be a serial interface, but I don't have serial interfaces on EVNG. So that's why I left it as is. Let's make it point-to-point. And then it did that. Now we have a potential. Now we have a mismatch here. So it tore down that relationship, I believe. Or actually, it bounced it, folded down, and then loaded in full. So it came back up, indicating a network type mismatch. So we need to go to that interface and fix that right there. So we made this P2P, point-to-point, point-to-point, and but we didn't. We left this as is as a network. So we need to change that type. Right, and let's verify our work. Show IP OSPF interface GI 0/1. Right, we see it is point-to-point, and then it should have changed the timers, right? 10, 40, 40. No, it didn't. Not yet. Not yet, at least. It's still set to 10, 40, 40. Let's go to router 2. Change that. Interface GI0/1. Is that 01? I can't remember. Yes, GI01. So GI01. And we said IP OSPF priority. No, not priority. We just did it. Y'all can see I'm ready to go, right? Network. And the network type was going to be point to point. Point to point. That should bounce that ass. Bloop, bloop. Come back up. Let's take a look at the interface now. Show IP. Show interface. So what was I going to do? Show IP OSPF interface GI0/1. And it still left the timers at default. So that's weird. I thought it would have changed that. Y'all know what happens there? Because we said the default timers would change. Or not that it would change, but it's different on a point-to-point network. So I thought that would have changed the timer intervals. I guess not. And I guess I have more labbing to do when it comes to point-to-point network and changing the defaults and stuff like that. But we know how to change them, but how to change the defaults. Anyway, like, comment, subscribe to the network.